slack. Okay, here. Okay, first one is elastic, right? Okay, the second one is inelastic. Okay, the third one is perfectly inelastic. Okay, okay.
Not perfectly elastic.
Sorry?
Perfectly elastic.
That's a piece of nonsense.
Perfectly elastic is elastic.
Perfectly elastic is elastic because you can't find something which is elastic yet which is not so perfect. So you don't have an imperfectly elastic, but it's a redundant. It's a redundant word. Okay. So elastic is perfectly elastic. Okay, you only have perfect, not perfect. Then it's not only elastic already. Okay, so inelastic have perfectly inelastic or inelastic. Perfectly elastic, just one more piece of information from elastic. It says that the two objects are moving together or embedded together or crushed. They become one body. They kind of things. They keep moving. Okay, so these two in the calculation y is the same. Okay. But this one just to tell you from there onward they travel together. So the final speed, right? You can use m1, m2, treat it as one body and come and read the kind of things at the right hand side there. Okay, these things. Well,
the left hand side is m1 v1 m2 v2.
Yes, m1 u1 m2 u2. Okay, so elastic is the elastic. Inelastic just to tell you that Ke is conserved. Okay, Ke is not conserved. Okay, that means Ke initial equal to Ke final. Ke initial not equal to Ke final. Okay.
Yeah, perfectly inelastic.
Perfectly elastic is inelastic, so Ke initial.
Perfectly inelastic.
Perfectly inelastic is elastic or inelastic also.
Oh, yeah.
So Ke not conserved. Okay, but one more piece of information is that
totally
they
not.
move together. They will become one body.
Oh.
Okay. So we will smash somebody, you and he become one, the kind of thing that become totally elastic. So we can have a common velocity, treat the two bodies as one body. Okay? So if this is the case, right, when it is taut, and after this one jerk, right, and if they move together with the same velocity, okay, it's treated as this. Got it? If it jerk and slack, okay,
But
it can be this and this.
We'll have the inertia.
What inertia?
If there's like two balls and they're straight, like if you jerk one time then you hold it and this ball still jump to the front.
Yeah, but that is another impact. And when remember we talk about the jerk and right after the jerk. After the jerk you have any frictional loss whatsoever. That's another topic. It's just before impact and after impact. That's the conserved momentum. Okay? So first impact, second impact, and third impact, fourth impact, you keep playing. Kind of things. Okay, so conserved momentum says m1 u1 m2 u2 equal to m1 v1 plus m2 v2. Conserved kinetic energy says there's half m1 u1 square plus half m2 u2 square equal to half m1 v1 square plus half m2 v2 square. Okay, so this is only for elastic. This is for all. Okay, inelastic you can't use it. Perfectly elastic you can't use it. Okay. Okay, and then secondly, know that this is vector. This is scalar. Okay, so what does it make a difference? It makes a difference when you have you only learn head-on collisions, right? Do you learn slanted glance, right? You learn glance?
Yeah.
You learn glance also?
But we don't, I think our questions we don't have calculations of glance.
Yeah, glance is not in your syllabus long ago. But in order to illustrate this to you, right? Glance collision is one of the good example. If before we hit is like that, and after we hit, right, it is like that.
Yeah.
The idea is that these things, if it is elastic, okay, these things apply in an axis. Okay, so what talking me is that don't need to know in detail. Okay? So let's say this is u1, and this is m1, and this is m2, and this is 0. So and this is v1, and this is theta 1, and this is, let's say, theta 2, and this is v2, this is m1, this is m2. Now if that's the case, right, okay, you will say this have two equations. The first equation is that horizontally, m1u1 plus 0 equal to m1v1 cosine theta plus m2v2 cosine theta 2. Okay? But on the other hand, right, you can actually have a very special equations about conserve vertically. Okay? In conserve vertically, right, initially this one have no vertical component, so 0. This one also have no vertical component, so 0. Okay? Which is equal to m1v1 sine theta 1 minus m2v2 sine theta 2. Okay? So bring this over, actually you have another equation. Okay? So this is why I say this is a vector. Got it? But if you talk about conserving energy, right? Okay, you don't talk about we talk about the if this elastic collisions. Okay, you still got to use the same thing. You cannot use any component. Okay, just use the half m1u1 square plus 0 equal to half m1v1 square plus half m2v2 square. Okay, you have 3 equations. Got it? Okay. And remember, when do conserve momentum, we only talk about the instance that before it hit and after it hit. We don't talk about after it hit, after that what happened later. That's not the conservation momentum. Okay, last piece of things you need to know is that if a special case, which is very, you actually have a, do you have the derived equations?
Yeah, derived what?
From the conserve momentum and conserve energies, right? You actually have one very handy equations, which is like v1 minus u1 equal to v2 minus u2 over something, that kind of thing.
Is it relative speed relations?
Yeah, relative speed relations. Okay.
Yeah.
Yeah. Remember, right? This relative speed relations is only when it is elastic. Okay, elastic. So how does this equation come out from? Is that you resolve the momentum and the kinetic energy simultaneous equation to get this answer. Okay, so if this is not elastic, right, you cannot have this answer. You only have the momentum conserved.
Can you go through how you can use this one to solve stuff?
No. Normally you may not want to use the conserved energy. Okay, so with this elastic, just use this and the momentum.
This is for MCQ, right?
For everything, actually, you just use it. Because you don't want to do square, square you have a quadratic equation. But you will still get the same thing because this one is derived from the 2 equations.
For this, is it the mass or the same? No, right?
The mass
Need not to be the same. Need not to be the same, but they get cancelled in the substitution procedure. Example. So you need to use this equation because you need to use 2 equations. You need to use 2 equations because you have 2 variables. Okay? So let's play around with 2 variables. 2 meter per second, and let's say this is 5 kg hit with let's say 10 kg with 1 meter per second. Okay, the mass is known. Okay, so 2 are known. Okay, let's say for the final speed. Okay, v1, v2. Okay, and it's elastic. It's elastic collisions. Okay, so how to find v1 and v2? Then you need 2 equations. So conserve momentum tension 2 times 5 plus 10 times plus 1 is it? Okay. 1 times 10.
Negative 1.
Oh yeah. Okay. So 2 times 5 minus 1 times 10 equal to
V times
5 v1 plus 10 v2. Okay.
There you can see there's a number there.
Yeah. Then the 10 and 10 is 0. So nice.
So 5 v1 equals.
Yeah, maybe. Okay.
So v1.
Another equation is this relative velocity, right?
Yeah.
u1 minus u2,
So
u1
2
minus
3 equals to 2
yeah,
minus
minus 1 equal to
equals to 10 5 10 minus 5.
v2 minus v1.
V2 minus
Don't bother, okay? So be very careful. I always got to better look at it. Okay? So 1, 2, this is 2, 1. Then yeah.
Throw inside you can find.
Okay, so substitute these things inside here. Okay, solve for V1 and V2. Okay. So two unknown, two equation when time we need, just use this instead of using the half mv square, half m square. It's the same, okay? Actually nowadays it's the same. Even though you come out with a lot of square, you pump your GC, it's still okay. GC can give you a graph and go to cut the intersection and you get the answer. Okay? You know how to use your GC?
This calculator also can.
Oh, yeah. Last time don't have.
GC not very good.
GC, you need to master it, okay? Yeah, sooner or later you need to master it. GC got 4 mode. You need to be familiar with matrix mode, list mode, graphic mode. Yeah, list mode, matrix mode, graphic mode, and
what's list?
List is like Excel. It's very important, okay? List mode.
List for maths.
Is for.
You only know matrix.
List mode, will it teach or not? I don't think so. List mode
alternative normal arithmetic method. Right?
That would be very slow. At least if you have at least one of let's say 10 data.
List stats.
Stat is one of the use. Anytime you need to do a lot of repetitive calculations, you can have list 2, then you key in another 10. Then you can do something called list 3 equal to list 2 times 2 plus list 1 squared. Kind of things, right? Then everything come out already. Okay?
That's Excel.
Yeah, and sometimes you need to step the increment, then you put 1, 2, 3, 4, 5, 6, 7, 8, 9 here. Then you do something right with this. This one is 2. Okay? This operation is actually quite important. Otherwise, you press 1 by 1, you may get a lot of error. Okay, and you must know the graph mode, right? The graph mode can go to list mode also. Okay, press your second graph. Okay, you can see the coordinate inside, and they always step by every increment of how much. You can set it to 1, then you get a whole list kind of things. Okay, good. Hey, whatever it is, okay. Momentum. Any more questions? You want to try?
Actually, I got one maths question.
Yeah. You ask me, Max. Why not?
It's like this guy earns